Welcome back. Today we are tackling the most dangerous misconceptions in software security. The belief that integrity is the same as control. Because code signing uses sophisticated mathematically unbreakable cryptography, it is often treated as a final release control. But cryptographic integrity is not governance. It proves that the code was not altered, not that it was authorized, reviewed, or appropriate to release. Today we are going to look at why that distinction is the difference between a secure enterprise and a compromised one. There is a belief that is widespread across engineering and security teams. If the signature is valid, the release must be trusted. A valid signature creates a feeling of confidence, but in an enterprise, confidence is not control. Code signing is a technical binary. It answers only one question. Was this artifact altered after the signature was applied? It is a check for tampering, not a check for permission. Let's be very clear about what a digital signature actually guarantees. It proves exactly two things. First, that the artifact was signed using a specific private key, and second, that the context has not changed since that moment. That's it. It does not prove who approved the build, it does not prove why it was released, and it does not prove whether your company's security policy was followed. It provides authenticity and integrity, but it remains silent on the question of legitimacy. True enterprise control requires answering much broader questions. A control system asks, who requested this release? Who peer reviewed it? Under which policy was it generated? Was the vulnerability scan clean? Code signing has no native concept of intent, approval, or authorization. You can sign a piece of malware just as easily as you can sign a critical security patch. The math is the same for both. Control is about the why and the who, not just the what. Another major gap in the timeline. Signing is a single point in time event, but the trust it creates lasts indefinitely. Once software is signed, that trust becomes static. There's no revalidation of the business case, no contextual check at the moment of execution, and in many cases, no easy way to revoke that trust once the software is distributed. Real control systems require continuous or contextual validation. Code signing by design is a fire and forget mechanism. We must accept this reality. Integrity is orthogonal to authorization. An artifact can be perfectly intact and yet completely unauthorized. Enterprises routinely discover signed binaries that violate internal policies, bypass mandatory reviews, or originate from compromised pipelines. Despite these massive governance failures, those binaries remain trusted by every server and workstation they run on because their cryptographic integrity is still intact. They are legal in the eyes of the math, but illegal in the eyes of the company. This creates a dangerous false sense of security. Because the underlying cryptography is mathematically strong, organizations often assume the governance system built on top of it is just as strong. This is an illusion. It masks the fact that the actual authority to release software is often unmanaged and invisible. We spend our time worry about bit rot and man-in-the-middle attacks while the front door of our release process is wide open. In the world of DevOps, this gap is widening. Our continuous integration or continuous deployment pipelines sign artifacts automatically at high velocity, sometimes hundreds of times an hour. No human being is reviewing each of these signing events. In this environment, integrity is perfectly preserved by the automation, but control is completely absent. We have successfully automated the production of valid signatures without automating the checks and balances that make those signatures meaningful. The problem is compounded by our operating systems. OS loaders, update systems, and mobile platforms are designed to validate signatures, not governance context. Once a file is signed with the enterprise key, this platform treats it as safe, period. They don't check if the developer was fired yesterday or if the code passed a static analysis test. They only see the signature. This means that if a signature is applied, all downstream defenses are essentially neutralized. If you look at the most sophisticated supply chain attacks in recent history, a clear pattern emerges. Abuse occurs within the trust boundary. Modern attackers rarely bother tampering with binaries after they are signed. Instead, they compromise the build system or the signing keys themselves. They produce artifacts that pass every integrity check perfectly. The bits are safe according to the signature, but the intent is malicious. This is the ultimate failure of integrity-only security. The consequence of this for the enterprise is that control gaps are only discovered after the damage is done. Because our integrity checks succeed, every time a signed file runs, we have no early warning system for unauthorized software. We often only discover that our governance has failed during a post-incident investigation, a grueling audit, or a regulatory review, long after the unauthorized software has been distributed to our customers or installed on our servers. To conclude our topic, integrity proves the safety of these bits, not the legitimacy of the release. Code signing ensures that what you received is what was signed, but it does not tell you if it should have been signed in the first place. Treating code signing as a governance mechanism creates blind trust in the software that may never have been authorized. In our next topic, we look at the fundamental trust model itself and identify exactly where it fractures in the modern enterprise.